Starting from this lesson up to a few more lessons, we will be learning about the limit of a function as x approaches a. And the first step to it is to understand what it means when we say x approaches a. So let's first see the meaning of x approaches a. We know that this x is our independent variable and a is some particular value of this independent variable x. And we know that the values of x are taken along the horizontal axis, which we call the x-axis. So suppose this is our x-axis, and let's say this point represents 1, this point represents say 1.1, this point represents 1.2, and so on. And let's say this a is equal to 1. This point is say a. Now, in order to see what it means when we say x approaches a, let's start from x is equal to 1.1. So let's first see that how close is this x, which is 1.1, from this a, which is 1. So in order to see this, we simply find the difference between the two numbers, which is x minus a. So in this case, x is 1.1 and a is 1. So the difference is 0.1. Now let's say the values of x get closer and closer to a. Let's pick a value of x, suppose 1.01. Again, in this case, in order to see that how close is this 1.01 from 1, what we do is that we simply find the difference between the two numbers. And in this case, this difference comes out to be 1.01 minus 1, and which will give us 0.01. Now, do you think the values of x can get further close to a without overlapping a or touching a? So in order to see this, I'm zooming in the space between 1.01 and 1. So let's say this is 1.01 and let's say this is 1, which is a. So although the difference between 1.01 and 1 is very, very small, which is 0.01, we also know that between any two numbers, there are infinite number of real numbers. So which means between 1.01 and 1, there are infinite number of real numbers. So which means that the values of x can get even closer to a without touching a or without overlapping a. So let's pick another value of x, say 1.001. So again, in order to see that how close is this 1.001 from 1, we simply find the difference between the two values, and that will give us x minus a as 1.001 minus 1, and which is 0.001. So what do we observe here? See, as the values of x get closer and closer to a, this difference x minus a, starting from 0.1, this difference gets smaller and smaller and smaller. And as we just discussed that between any two numbers, there are infinite number of real numbers, so which means this difference can be further reduced. So that is, as the values of x get closer and closer to this number a, this difference x minus a gets smaller and smaller and smaller, and it goes towards 0. That is, we can make this difference very close to the number 0. But we never take this difference as 0, because we can make the values of x as close as we like to this number a without letting x equal to a. So x approaches a, it implies that this difference x minus a approaches 0. So when we deal with x approaches a, we never consider x is equal to a. That is, x approaches a does not mean that x is equal to a. It means that x is very, very close to a, so that the difference between x and a is very, very close to the number 0. Now here we discuss the case when x approaches a from the right side. Now the exactly same thing happens as x approaches a from the left side, with the only difference that in this case, the difference between x and a will obviously be negative. See, suppose this point is say 0.9. So this is x and a is 1. So x, which is 0.9 minus 1, will give you a negative number. But the sign of this difference doesn't matter. We are only interested in the numerical value of this difference. That is, how close is this number x from a. So this is about x approaches a. And once we have understood the meaning of x approaches a, we are all set to learn the meaning of the limit of a function as x approaches a.